to 3 algorithm. Today we'll discuss, then we'll go for the hands-on. So as I discussed with you, let's see what we discussed. We already discussed the linear regression model, which predict the regression value. And another is the logistic regression, which is used for the classification. Then k nearest neighbor is used for both the regression and the classification. Today we'll go for the decision tree and the ensemble learning approach. Decision tree and the ensemble learning approach. So decision tree can be used for both the regression and the classification. So in the decision trees look like the flowchart tree structures as you learn in case of the data structures. So here you have the branches and you have some internal nodes. This is the parent root node and you have the leaf nodes. So from the data, you are going to create this decision tree. And this is a supervised learning approach, and it is used for both classification and regression, how it is, how you make the tree and how it is used for the classification and regression. Let us discuss one by. So first of all, let's learn some terminologies. You are using you are a term that is root node. As I said, this is your root node, the first row. It contains all the data, this row. Then the internal node, or you can say the decision node. This is your, these last are the leaf node, this green are the leaf node. Internal node is this one. They can be splitted into branches. It may have the two children here in these tree structures. Each parent node has the two children, but no, you may have more than two, but minimum two. And the last terminal nodes are the leaf node. These greens are the leaf nodes. In case of the regression, you will get some continuous value, and in the leaf node, and in case of the classification, you will have this class value here in the leaf node. Okay. Then the splitting and subtree is needed here. You see here all internal nodes and the root node also splitted. Okay, how it is splitted? And you have to follow some rule to split this one, the data. Then when you suppose you are splitting this root node, your whole data is splitted into non-overlapping two data sets. And again, this sub data set is create a tree. Here a parents node or the root nodes create a tree. Then this sub data set will create another tree. This sub data set creates another tree. Again, it is splitted like this. You have created the tree. So these are the internal nodes where you have to find some decision. You will use some rule to split the tree and make the soft. Okay. So again, the another concept is that when you are the question of the splitting is coming, how you will split this? How the features value is considered to split? You will calculate the impurity. The impurity means how, when you are seeing the data for suppose the class, you will say that one group, they have different classes. If they have more group of data having more number of different classes or the different values, you will say there is more impurity. So you want to, when you are splitting this in the tree, what happen? You want to find out all are of one class, this one of one class, or in case of the regression value, they are very close values. All instances of this group have the close values, or all instances of one class. Our purpose. If they have mix of too much classes or the regression values difference is very large, then you will say that there is more impurity. So our purpose is to find the features value. Basing on that, you will split the tree so that all similar type of target value belongs to one group. So for that, you will calculate to calculate the impurity, you calculate the Gini index value and the entropy value. Okay, for the classification. And for the regression, you will use the variance, that is mean square error, mean absolute error, you need to calculate. Okay. So another concept is information gain. If negation of the impurity is called the information gain. That means if your information gain is high, then you have less impurity in the data set, the group of data. So you need to find the data, so splitted the data in the subset so that all the splitted group are of the same, belongs to same class, or if in case of the regression, their values, target value are very close to each other. That means mean square error or absolute error must be less, and the Gini index entropy must be in the information gain is high and impurity will be low, entropy will be low. So pooling is that some concept first, that is some branches need to remove. When you use this algorithm, this concept to make the decision tree, to find some rule, in that case, there needed to some branches to remove. Remove means you will make stuff there to not split. You see here in this tree, you don't need to split somewhere. Here you don't need to split. You don't need to split. And again, somewhere it may be the same class, so you are not splitting. But in some cases, they may not have a mix of more classes, or mean square error is their difference is more than 0. Still, you are not splitting. Your tree, in this case, some branches are removed, not needed to do, because of some region. And if you do that one, you will find the overfitting. For that, you will not create more children of some internal nodes, and you will remove that one to avoid the overfitting. So that is called pruning. The removing the branches from the tree that do not provide any additional information or lead to overfitting, those branches are removed. So here is the algorithm, common algorithm. First of all, you will consider the whole data set, and that will be set the root node. Then you will select the features. You have so many features. Among them, you will find the best feature, best attribute to split. According to its value, the tree is splitted. Okay. So again, splitted means that means what? You will, according to value of some attributes, you will divide the data set into 2 or 3, 4 parts according to the value of the attributes. Okay. 4 subset of data set, like that, 2 subset of data set according to value of the attributes, will split it. Then you will have generate the decision tree node which contains the best attributes. So that will be your decision tree. You will say according to some best attribute, you are splitting and making the decision tree. Again, you have after splitting, you may have to split it into 2 or 3, 4 like this. All if you are splitting into 2, then you have 2 child nodes. If you have splitting into 3, you have 3 child nodes. You are splitting into 4, then 4 child nodes, and all child's node are divided, or contains the data set. From the whole data set, you will consider subset of the data set. It must have some data, and that data set, and it is the subset of this whole data set, and their intersection is 5. The data sets you are splitting all are not overlapping strictly. They are independently splitted. And you will, for all the child node, you will do the same thing. After selection of one attribute, rest of the attributes consider for the child nodes, and there also you will select the another best attribute for each corresponding child node. Again, you will do the same approach. You will go on splitting it according to the value of the attributes, best attributes you select. How you find the best attribute? You will use the attribute selection measure approach. What is this attribute selection measure approach? We'll discuss. So, so see here, regression decision tree, how you are creating. You have two attributes here. Year of experience, let it be say X1. Another, the previous year. So here you have to find the salary in lakhs of USD. So how you will do the decision tree with this data set? Base per player salary is to be decided. These are the continuous values, so you are doing the regression. See here, you will say that if X1 value less than equal to 4.5, X1 means year of experience. Year of experience is less than equal to 4.5, then you will say it belongs to region R. Okay, that means you will consider R as all the data set which X1 value is less than equal to 4.5. That means here your X1 value, this is 3, this is 4.75. And you are finding here 4.5. So this is also not belongs to class. The belongs to region R1 is only this one, because only this one is less than 4.5. So you at the region R1, you have instance player 1 is there. Okay. Then rest of player is how much? Rest of player is, you have total 5, out of 1 is of region R1. Rest 2, 3, 4, 5 are region R2. You reach another region. In that case, you are saying that X1 value less than 4.5. So see here in this graph, if you are saying the X1 value is less than 4.5, this belongs to this R region. And you are taking x-axis as the X1, and this axis is your X2. Okay. So according to this value, this is your 4.5, and you are saying up to this region are 1 class, 1 instance, first one. Rest is here 4 instances. In this region, you have 4 instances where your X1 value is 4.5. Now here you need to again divide according to X2 values. You will find a point 1 to 125. Basing on that, you will split it, and you find here, if you will take that X2 value is less than 125. So you can say this belongs to 120, and this one is no needed to consider because it's already of different groups. Now 125 means only this one is of the group, so rest are of the group, another section. Another one. So you will find R2 is of here X2 is less than equal to 120, and this R3 region X2 is greater than 120. So R3 contains the elements here 3, 4, 5, and R2 contains only 2, R1 contains 1. So when a new person come, you say that its salary is 6.5. Year of experience is 6.5, and the number of years in the previous year is 170, then what will be his annual salary? Then we'll go to the decision tree. This decision tree, you find that the 6.5, This 6.5 is greater than 4.5. That means this belongs to this region, this side. You will not consider for this side. Then what you will do? You will consider x2. What is the value of x2? 170. It is greater than 125. That means it is of region 3. Then what will be its salary? Its salary is of region 3. Region 3 means 3, 4, 3, 4, 5. That means what is the salary? 1.2, 1.3, 1.5. You will add these 3, divide with the 3. That will be the salary of this new person. Okay. In the region R3, you have 3 players, 3, 4, 5. What will be the salary for X? For X1 is 6.5, X2 is 170 of region 3. Is that you will add all the instances which is belongs to region 3 and add this and number of players, that is divided by 3, that is 4 by 3 lakhs. So in this way, we can use the regression approach. Here you are predicting the salary. So in the decision tree, as I explained you how you split it. And our problem here is how to find this 4.5. How you find this 125? Okay. So here what's happened, you will see all the data and you will analyze this data. There is so many mathematical technique is there. That technique will be used for the classification. You will find out the Gini entropy value or gain value, information gain value. And accordingly, you will choose this splitting point. Where will come? Which attribute fast? Again, another question is that why fast x1? Why not fast x2? And for that also, you will use some mathematical calculation and find out which one will be best to first consider and at what point we'll consider. Okay, so that will be your that is calculations is there. Basing on that, we'll consider this thing. I already explained you just here. Here how region is created. Same way you are considering. Here what's happened? This is the total data set. You can see this is total data set. Then according to the value of x2, this is x2. It is x2 at splitting point is s2. And when the x2 value is less than s2, it belongs to region B. And if it is greater than s2, then it belongs to A. Then we'll consider another attribute x1. So when you consider the x1, you will find that for the B region, when you are considering x1 less than s1, it is belongs to b1. When it is greater than s1, it belongs to b2. So how you finding this? Again, you are considering for the a value is, what is the value a? You have to find again. If it is less than that value, suppose it is S3, it is less than S3, it belongs to A1 group. Greater than S3, it belongs to A2 group. So you will go, in this way, you will split and correspondingly, you will find the 4 region. How many attributes is there? Correspondingly, you will find out regions. Okay. But one is that if you have 1,000 of attributes, not needed to consider the 1,000 attributes. Here you can do so many pre-processing approach. Finally, you will, after as I explained you previous class, how to pre-process, how to select some attributes, how to feature extraction can be done. We'll also again will discuss all this with the data set. Then after doing that, how many features value will consider? Among them, you will consider some features value for making the decision tree. So finally, after finding this region, you can create the decision tree like this. Your root value is here, this one. Root 1 is considered first x2 is splitted. This is again after the x1 is splitted here. A is less than equal to S1, it belongs to region 1, greater than S2, region 2. Here X1 is less than S3, region 3, greater than equal to S3, that is greater than S3, it belongs to region R4. These are your leaf node. And this is your internal node, this is your root node. Okay. This is about the regressions. Yes, this is there is some approach I have explained you how to consider the features and how to consider the splitting point. Which features will be considered first? Here I have noted two. One is saying that which features is considered first, then next one, then if in your data set p number of features, then which one will be considered first, so that we in the less depth of the tree we can able to split the data set to find the class, okay, or find the region to predict the values, numeric values or for regression. So the two thing is that first is which features will be considered first in which sequence. Then another is the what is the splitting point of the attributes. Like here your splitting point is S2, this is S1, S3, how you find. So here is some the mathematical technique you will consider for all the points. In case of the features value, you will sort it in non-decreasing order. Then the consecutive two values average is taken, and that will be your splitting point. And according to that split point, what will be the value will be predicted for a person is considered. Then how much for all the training data, then how much error will be there for the you will calculate these error values. Okay, what is the real value, what is the predicted values, different between them will be considered. Here the splitting point is Sj, and for the region R1 you are saying that it all the value less than equal to Sj for the attribute Xj. Similarly, for region 2, you are saying that all the value greater than Sj. This is less than equal to Sj, greater than Sj. Like here I am described, less than equal to some value, greater than equal to some value. S1 is a similar way. Here I have defined. You have considered the attributes and its splitting point, all the possible splitting point. Then correspondingly, you will find out the regions or two regions. Then accordingly, you will find out the what is the predicted value using the average value, finding the average value, like in case of your regression, I said you. So correspondingly, actual value and the your predicted calculated value difference you have to find for all. Then what is the error you can able to find, that is RSS. Okay. Then residual error, square error. So after finding this error for all the splitting point, you will find which one will be the less error, that point will be considered. So it is very time taking, but you use your computer, so it will do all this. Manually, if you will do, it will take too much papers and too much time also. Then that in this way you will do for all the attributes in the data set. Which one will be give the among them? Which one will be give the less RSS value? That attribute will be selected for the splitting. And the point you find at which point it is giving the RSS value is very low, and in that point we'll consider. So it's a very difficult task. Time-consuming tax also. So you already have the library. You can use that, which approach you will use, and what is the splitting point, all it automatically find out. Okay. Now, what happened for the regression tree? Begin the tree with the, as I explained you, the algorithm, whole data set will be there. And for all the attributes, you will consider the case I just explain you here for each attribute. Suppose you have the 5 attributes. For first, you will take first attribute, and whatever value will be there in the data set, all will be sorted in the non-decreasing order. Then consecutive 2 data set will be average will be find out consecutive. Then that will be the splitting value will be considered, and in that case you will taking the splitting value, what will be the real value, what is you are taking the average value, what will be the value, the difference will be find out. You already calculate how to find the standard deviation, same way you will find here. So RSS value, so two region you have to, for one region the error is this much, for the another region error is this much, all error will be added, then you find how much RSS. You go on finding for all non-decreasing order, sorting order among the midpoint. For all midpoint it is tested, for which it is give the less value, that value will be considered for that attribute. And this thing will be do for all the attributes. Okay, all the attributes. So you will continue this one for all attribute. For among them again you will consider which one is the giving the all RSS to less. That attribute will be selected. Okay. So using that attribute, whole data set will be split into regions. Okay. Then you have two sub data set. Again you will, for the sub data set, again you will do the same procedure. For taking as the whole data set D, you will do the, for the all sub data set you will go on doing recursively. And when you will stop, when you find that there is all there is fewer than some minimum number depth is coming, you will fix a depth of to that depth it is splitted, and in that case you can stop. Or you will find that the all the values of a regions, all target values of same, in that case you can also be stopped there. Okay, or you can fix a depth up to this depth, you will stop to split the tree. So in this way, you can make the regression tree. Another is the classification case. In case of the classification, you target data at the class 1, 2, 3, 4, like this. You have the class. Okay. So in that case, you will calculate the, again, same thing. Since the attributes are the numeric value, you have to find the region. But here, you are calculating the RSS value. Since the predicted value is the continuous value, you are taking the RSS values and mean square error value or absolute error value like this. But here, since you have the categorical, in case of the class, you have the categorical value 1, 2, 3, 4 or 0, 1, 2, 3 like this, you have the value. In that case, you have to find the probabilities value, or how much it belongs to one class, you have to find how much probability that it belongs to that class. Okay. So after that, you will consider here, in that case, according to that, how much, in which point the probabilities value you are considering for one class is 1, and how much probability belongs to one class you are finding the higher, or it becomes one class, all the group of data belongs to one class. In after that, he will go on splitting. So here also same thing, same problem. Like in case of the regression, you have the same problem. Which features you need to select first among the P number of features in the data set, which features you need to consider first. Then splitting point. What is the splitting point? Same thing. You need to find out what is the splitting point also. So here we also need to find the splitting point. Another is in which order the attributes need to be split. For that, you have to calculate either the Gini index or the entropy. Okay. How you calculate the Gini index and entropy? The formula for calculating the entropy is that minus summation I is 1 to n pi log to pi. Pi is the probability of randomly selecting an example in class size. And what is the information gain? Information gain is entropy for the parents minus entropy for the children. That is unit. If the information, the splitting point at which the information gain is high, that point will be choose for your splitting. Okay. So here is an example. Suppose this is the data. What is the data saying? That is target variable exam result, whether it pass in the, say this is your serial number, and exam result pass, fail, fail, pass, fail, pass, fail, like this. And this is whether the person did any online classes, yes, no, yes, no. Another is student background, that is whether he is of mathematics or computer science or any other stream. Working status, he is working already, doing some work or job or not. NW means not working, W means is working. So these are the information you have, and you want to do the classification work. So here you have to calculate the entropy. What was the formula? Minus summation of pi. Pi into log pi. This is pi into log to pi. 1 to n. So what is the meaning of that? You see here, you target value is, first of all, you will find the entropy value for the parent. Then you will find the information gain. Okay, here is the formula. This is your entropy value and this is your information gain. So how you will do? First parent is your ace, no, fail, pass. You are saying that how many number of pass? 8 number is pass. How number is fail? 7 is failure. So your entropy for the parent is, total number is 15. So probability is 8 by 15 log to 8 by 15 minus 7 by 15 log to 7 by 15. So when you calculate, you will get 0.9968. So parents entropy value is 0.9968. So for the, again, we will consider for all the attributes. How many attributes you have? See here, 1, 2, 3 attributes is there. First of all, we will consider whether he is doing any online class or not. So here you find that yes, some are doing yes, some no. Why no? Why no? Yes, no. So accordingly, what is his target value is pass, fail is considered here. So for suppose you have Y here, yes is here, online class doing is 8, no is 7 here again. So for the S 8, you find that S, for the S, this is pass, this S is fail, this S is pass, this S is fail, this S is pass, this S is pass. Correspondingly, we calculate for the 8, pass is 5, fail is 3. So what is the entropy for the YS here, online class doing? Is that minus 5 by 8. Total is 8, out of which 5. So probability is 5 by 8. So minus 5 by 8 is log to 5 by 8. Then 3 by 8 minus 3 by 8 log to 3 by 8. When you calculate, you will get 0.954. Similarly, for the no, you will calculate the value is 0.9852. Then finally, entropy for the online course doing or not is that this is your 8 by 15. Out of 15, 8 is A. So 8 by 15 into what is the entropy of Y? 0.9544 plus 7 by 15 into 0.9852. That is for the no. If you add this, you will get the information here 0.968. So entropy here. Then what is the information gain? Parent entropy minus this attribute. Your parent entropy is 0.9968 and your other online course entropy is 0.968. If you do the subtraction, you will get the information gain is 0.028. This is for the online course. Similarly, you will consider for the student background features. Here you will find that the 0.5370. Next, you will consider for the working status. Here you will find that 0.1858. So finally, you find out that, yeah, I have summarized here, when you are considering working, non-working, and you are finding the information gain is 0.1852. And for the background, mathematics, computer science, others, the 0.5370. For online course, the entropy is information gain is 0.0282. So among them, the information gain highest is 0.5370. That means you will consider the background. So accordingly, background, what is the background? You are finding that mathematics, computer science, author. So using this value, you will split. Here you are finding 3 type of values. So you will split into 3. Okay. So if you take the other course, you will find 0 pass, 4 fail. If you find the CS course, all will pass, 0 will fail. Then if you are finding mathematics, you are finding that 4 pass, 3 fail. Here you see that this belongs to one class, that is pass. And this belongs to also one class, 4 fail. That means any person whose background, any students whose background is author, he will fail, and any student whose background is computer science, he will pass, and any student background is mathematics, he may pass, may fail. So here you have the problem. So you only consider this data set which have the math background. Other not needed to consider. So these are become your leaf node. Only this data set is representing the to consider. So how many data set left that mathematics you will consider? See here, only math background is this much: 1, 2, 3, 4, 5, 6, 7. So now background is already belongs to a class. This is not needed to consider. Target data is the parent, is considered for the parent. Then you have only these 2, online course and the working status. Among these 2, you will consider one features to split. Which one you will split? Again, you will follow the same procedure. Now again, you will find out the parent node entropy. Again, you will find out the parent node entropy, and for this 7 data set, then you will find out for the entropy this online course, subtract it, find the information. Again, if you choose online course, again find the for working status. Among them, which one will be highest information gain, that attribute will be chosen. So here you find out the working is the you find out using that taking working, not working is 0.5216. Online course is find out 0.0219. So since this one is the highest value, so you will take here working, non-working attribute. Choose. After choosing this working, you will find this set 3 pass, 1 fail, working. And for the not working, all are pass. So you have now to consider 3P1F. Okay, here only left one attribute. That is your one attribute is your online course. According to online course, you find here, you see here, you find here that math background, working status is, and you find that this Y online course Y is fail, and online course no is fail, pass, combine is there. So here also this one is your last attribute to consider. So you are not finding anything. If you are finding A's online course, it positively fail. But for the no, there is no conclusion because one pass is there, to fail is there. In that case, you will take the probability. Pass probability is 1/4. Fail probability is 3/4. So when instances come and they, after doing, go on splitting at the last phase, when online course saying that AC is doing online course, then you will say that you will fail in the exam. And if you find that online course no, there is the probability of pass is 1/4, probability of fail is 3/4. Sorry, here is 3, fail is sorry, pass is 1/3. If you are counting whole, then 1/4, 3/4. If you remove this one, then we'll say probability of pass is 1/3, probability of fail is 2/3. So since the maximum is failed, so any portion will come, he will say that he will fail the exam. So online course, if have there, whatever may be the no or race, whatever may be there after splitting, in last split, you will say that you will fail in the exam since the probability is high. Okay, in this way, you will consider for the classification. Here you are considering the information gain. You can also consider for the Gini entropy. Gini entropy formula is 1 minus summation of probabilities values. Okay, so you will calculate the same question, you will calculate probability of everything. Then you are doing the, for the parents, you will calculate all cases, will calculate, and correspondingly you will evaluate which one will be the highest value that will be taken for the splitter. In this way, you can use any formula. For some data set, Gini entropy is better, and for some other data set, your information gain measurement is better. Okay. So in this way, you can form the decision tree. And for the classification and regression, this is the whole data. For the Gini entropy, it is also same. If you use the Gini approach value, then it will also form the same here. Sometime it may not, but so overall, the algorithm for the classification of tree is that you will begin the same approach, begin with whole data set, then you calculate for the all attribute, you will calculate either Gini index or the information gain through the entropy. And correspondingly, you will choose the attribute which will be the best for, and correspondingly, you will split the tree and you will go on doing the split until you are not, it belongs to a single class like I described in the example, or you will come in a situations where it is not unable to split. In that case, you will take the probabilities value. Which probabilities will be highest? In that it belongs to, the instance belongs to that class, or you will predict the value for some features value as that class. So this is about your decision tree, how you make the decision tree. But if you have too much of attributes, if you have the data this much, you can do with your pen and paper, or you can use the calculator, calculate and do this one. And but if the data set has as in 1,000 or in lakhs or in crore is then in that case very difficult to use manually calculate the decision tree. In that case, you obviously use the libraries and the system, computer system. So next we'll discuss the what's the time, we'll go for the hands-on. So ensemble learning is that I'm just briefly saying that it is the, you will use multiple machine learning approach here. In that case, you only in the previous the algorithm I explain you the whatever is only one approach. You see, one approach you are using and consider predicting the values. It may be the regression, maybe the classification. You are predicting a values using only one approach. Here you will use multiple approaches. Okay. So same approach, like you will use the decision tree, and you will use the k-nearest neighbor and or logistic regression. All approaches you will use. Which one will be give the best one? It will be selected. Okay. So in that case, you will get a good prediction, correct prediction. Okay. Instead of using one approach, you may not get the correct prediction. If you use the multiple approach, and among them which you will choose one result, then you will get the best model to predict for the data set. Your model is suitable for different data, for different model is suitable, not that logistic regression will give the best performance with the all data set. Okay, for the different data set, different model is suitable. So in ensemble learning, what happen? You train multiple models and see the all model predictions. Then among them, you can use the voting approach. Which one is the best? You will find voting means so which class is more frequently predicted. That one will be considered belongs to. Suppose you are using decision tree, logistic regression, and k-nearest neighbor, and among them, which one is giving the better performance for all, then that will be all instances. Then that will be better accuracy. That will be considered. We'll go for that. How to calculate that one? We'll go to in the next class. Instead of going for the new models, we'll first learn how performance is measured. Next class. So another is average. In case of the regression, you will use the accuracies. Again, another concept is that weighted combination will be used for predictions in that case. That means you will use here the multiple approach and and they are considered in some way and predict the values. Okay. Like in by doing this way, what happen? We will get the better accuracy and robustness and generalizations. Okay. Like your one expert is teaching you or giving any solution or any opinion is better than the multiple expert will be analyze and give the opinion or just judge any decision. Then it is better. Okay. So ensemble learning approach is that you are considering multiple machine learning approaches and then you are predicting the result. By that, what happen? Improve the prediction accuracy, reduce overfitting, and can handle the complex data. Okay. So one of the ensemble approach is your random forest approach. This is a again ensemble approach are three types. One is your backing, another is your stacking, another is your boosting. So one of the ensemble approach is your random forest. Random forest is the bagging ensemble approach. If time permit, I will discuss all the ensemble approach in last classes. Okay, so what is the random forest ensemble learning approach? Whatever data is there, you will take a sample of all data, multiple sample you will take, and you will make multiple trees. Then after doing multiple trees, then among them, you will consider what is the performance of the which trees. And if it is a classification approach, you will do the mode, that is the voting. What is the measuring vote? And if you are using the regression approach, you will take the average predictions values. Okay. So here the random forest can be used for the both classification and regression approach. Here, what is the procedure here follow? You have vast amount of data and you will split the data. You will collect the data sample. Okay. Sampling from whole data, you will using the bootstrap sampling approach, you will take data, a subset of data. Then with this subset of data, you will make the tree. So you have more than, you may, according to your decision, you can take two minimum two tree. Or you can make 40, 10 tree, 100 tree, and all tree, when a new data will come, all tree will be predicted. Among them, which one, if it is a classification approach, among them, which one class is, suppose you make 10 tree, and for one new instance is given, all tree will be say you that it is of class 1. Out of 10 tree, 7 tree are saying that it belongs to class 1. And rest 3 tree are saying that it belongs to class 0. So you will take that the class is your S. Okay. So in this way, you will consider here. And for the regression case, what you will do, whatever the 10 tree will predict one value, one again, you will add all the predicted continuous value, then divide with the 10, what will be the value? That will be your final predictions values. Okay. So here is the example for the classification. Say here, you create a 5 tree, taking 5 samples and 5 tree, out of which first tree say that S belongs to class, 2 is S, 4 is S, and third is saying no, not belongs to class, 5 is saying no. So here majority is S. So the instance belongs to class S. Similarly, for the regression, what happened? You are finding that tree 1 giving 20.5 and tree 2 giving 11.5, tree 3 saying 30.5, 4 saying 21, 5 saying 50. So what will the predicted regression value? You will add all and divide with the 5. You will get 19.7. In this way, you will use the random forest. And how you create the tree? Same procedure I discussed now in tree here. You will follow same algorithm to build the tree with a subset of sample of data, not whole data. Okay, this is about your random forest. This is one of the ensemble learning approach. Ensemble learning approach 3 types. Here is one type is your random forest. Is using the same machine learning approach. Some approaches is there, like in the stacking approach, you can use the different machine learning approach. You can use the SPM, logistic regression, KNN, all approaches will be used. Among them, which is the best, you will find out the corresponding result using this same procedure. Okay, this is about your theory class. We will not discuss much more because you need to do the hands-on. Otherwise, last class also I unable to complete, and this class will try to complete whatever we learn about the model, machine learning model. We try to complete today. Okay, let's go. Will use the library? So I think it will complete very quickly. Is there any doubt? Is there any doubt? Hello? Is there any doubt? No? Yes, I will send. I already sent the PPT to sir. So today PPT I also sent to sir. Okay, after completion. Okay, let's go for the lab. Okay.
Today you are going to show all, na? Whatever things covered today that you are going to show. Okay, ma'am, am I audible? Hello. Okay, ma'am, am I audible? What happened? Let me call her. Okay, let me call to Rekha, ma'am. She is joining again. Some network issue. Yes, yes, okay, ma'am.
Yes, sir.
You can share the
So,
screen for the lab.
okay.
You can switch up your video. Switch off the video so the network issues are there. Switch off the video.
Oh, so video is showing. Okay,
Swing.
okay.
So you can switch off the video. Yes.
Yes.
Yeah. You are going to show all
So
the algorithms today, ensemble learning and all other free.
yes, I'm trying to complete today.
Okay, fine.
So that tomorrow I'll discuss the how to measure the performance accuracy, all that
Okay, okay, okay. You
thing.
can continue.
Yes, sir.
Yeah.
Is it visible?
Yes, yes.
Okay, we are going to. We already discussed here the models linear regressions and logistic regression. k nearest neighbor models. Today we have to discuss decision tree ensemble learning and the how to write the code. I also explain you the library you can use, how to load the data set, all this. For the linear regression, you have to include this model, sklearn dot linear model, import linear regression. Then you create the instance calling the model regression model, linear regression, any name you can give. I have given you the regression model. Then you feed on with the data set this one, and for the new data you can predict. So for the logistic regression, it is used for the classification. Linear regression is used for the regression. This one is used for classifications. And for that, you have to load the linear, from the same linear model, you have to import the logistic regression. And race thing is same as I explained for the regression. Then I have discussed about the k nearest neighbor model. Here there is model is that sklearn.neighbors import k neighbors classifier. Then same way, you will use the k neighbors classifier, create the instance, and you will have the model. Then you feed the model on the data set. Then for the new data set, you can predict this one. Okay. Similarly, for the regression k nearest, that is this one I discussed for the classifications. And for the regression, you will consider same model neighbors, but you will call here the k neighbors regressor. Here you have the k neighbors classifier, and you create the instances classifier. Here you have the regression, and you will find out k neighbors regressions. And I explain you about the k value. Here it is taken 3 k value. You can take the 5. Generally, you have to take the odd number, 3, 5, like this. And after creating the model, you will feed on the data set, same thing you will do. Next, you have the decision tree. Today I discuss. Here you have a model sklearn.tree. So from sklearn.tree, you will import, if you are using for the classification, then you will import here decision tree classifier. Then you will use here, create the model, like model is equal to decision tree classifier, whatever is written here. Inside it, some parameter you have to fix here. If you will not give any parameter, then it will automatically take the Gini entropy, and the depth of the tree is 3. And if you will not fix the random state, then it will go on changing your splitting value, parameters values, all this. Any value you have to write. No, not compulsory 42. You can write here also 0. Any value you have to write here, so that whatever data, when you will use the data and train the model, that model will be same always. Splitting value, all parameter value, and the Gini entropy always is used, all this. Otherwise, you, whenever will again run the code, it will make different. Okay, so you have to write here something, random state 0, 42. Generally, it is written 42. There is no any specific rule to write any 42. But generally, it is assumed that it is a lucky number. That's why it is writing the 42. So then after creating this one, you will write here the model.feed xy, same procedure. Then you will, for the new data, you can predict. Then you have the for the regression, you have to include the same tree, but you have to include the decision tree regression. Okay, same approach. Then you create this one. Here, since it is the classification approach, so you have used the Gini entropy, or you write there also information gain. Okay. So here you are using the regression, so you have to calculate here the squared error, mean square error, okay, or absolute error. Or generally it is calculate the mean square error. Okay, depth of the tree is taken 3. You can take any depth. You can write 5 7 generally odd number. Then random state is 42. This is to maintain the data set similar form. Okay, similar parameter, all this thing will be same. Otherwise, if you run, whenever you run, it will change everything. Then next is the you will same way you will feed the model on the data set. Then for the new data set, you will predict. So next is your random forest ensemble learning approach. Here is a model ensemble. So for in the sklearn library is defined. So from sklearn dot ensemble import random forest classifier. First of all, we'll discuss about the classification. So yeah, I have right here the classifier, or if it is regression, then you will write the regressor. So again, you will create the instance here. Model is equal to random, whatever is written here, random forest classifier you have to write. And here is a parameter n estimators. N estimators mean how many samples you will create, how many tree you will create here. So I have given here the 10. That means you will create 10 trees. So next is which entropy with the samples data you also use the measurement, impurity measurement. So in that here you have Guinea is written and death is taken 5, random step is 42. And after creating this one, you will feed with the data set, then you will predict with the new data set, you will predict correspond. Similarly, for the regression, you will do the same. Only the here is written random for a regression. Same sklearn ensemble on inside the ensemble class. This random forest regression is defined. So you can call this one. You will call this one here model here n estimate 100 means you will create a 100 trees. When the data choice is very high amount, huge amount is there, in that case you can make more tree, more sample, more tree. So 100 means 100 tree will be created. If there is less number of data, then this is not so the parameter should not be 100. You have 100 data. How can you will fix the 100? That means one data you will create. So samples, but it is possible. It is possible to create because random forest using the bootstrap sampling approach. According to bootstrap sampling approach, if you the data sub-data you are taking for creating the tree, they are overlap. They are not independent. Their intersection is not 5. Sample set intersection is not 5. They can overlap. So you may not, you can take 100 samples by repeatedly considering some samples. So depth of the tree is taken 5, random state is 42. This parameter you need to fix. Otherwise, if you not fix anything, it automatically take some fix. Generally, it is taking the 100, depth is taking 5 or 3, like this. It is taking. So same way, you will feed the model on the data set, then you will, when the new data will come, you will predict this one. So let us see how it will be considered for the in Python. Only because our time is not permitting to complete. So I feel it is better to do. So in the previous class, I discussed that from you will use the files. You can use the drive and the or files according to file import class. You can use the file class and upload the data set by running this one. I already show you running this one. It will say you to choose a file. So this is running. it will choose the file is writing, then immediately you click on the choose file. Then in your system where you have kept the data set, you just you are using for the regression data set. This is a regression data set I showed you on the last class. Then you will that data set you load inside here. You need to read that one to access the data. So to read that one, you can write, you have to install the Panda. So import Panda and the nickname given VT. I already explained you these things. So you have given the data frame name as the DF. So read this data. After that, when you write the df.head, it will show you the 5 instance. Here is the data set. You have the area, square feet, bedroom, bathroom, floors, age, location, what will be the price of the home. This is your price, is your target data, that is regression value. Others are the area, square feet, bedrooms, bathroom, floors, age, location are your features, attributes or features. So next, if you want to see the safe, you can write. If you want to only try to what are the columns, you can write here df.columns, you will find. More important thing is this one. What missing is showing you, and you have 100. As I see here, the shape of data is 100 rows, 100 rows, 7 attributes, including the target data. So you see here the 0, 1 to 7 attributes, and all should be 100. For some have no 100, some are 88. This is 92. This is 80. Another, you observe that all are the numeric. Only location is the string value. String value cannot be used for calculation, numerical calculation. So we need to convert it. Okay. So since you are from this is 92, this is 90. So you first make it 100 by when the value, where value is missing, you will, suppose you want to keep that the mean value. Okay, so you can write this syntax. So you can use the imputer directly, create a model for the all the pre-processing, then do. But I find that this is not working better. So I just do individual. So you can try that one. That one also working with my system. Bathrooms, and you are finding the age here missing. So correspondingly, I fill it. Here you calling the meal dot in place true, this one. Then when you see the information, again you find that, see this one, after running that one, age becomes 100. And the price, another one was, this one is, see here, bathroom was 88, it becomes 100 also. This is also 100. Only left is location, which is 90. Again, it is type is, it is object, that means string data. So first of all, we'll cover the missing data. Where is the missing data? We'll keep that the mode value. So for that, I have right here the location, df location dot filna df location dot mode. Here this syntax df location dot mode to this bracket end is finding the mode value. This is the syntax in your Python. You can see that one. It will find the mode values. And after that, you will fill that mode. When you write the filna, it will fill all the missing value with the mode value. So now if you write the information, see the information, you will find out that, see here, location is also 100, but these are object. Since this is object, it cannot be calculated as a numeric value. So you have to convert it into the numeric value. I have used here the 1 hot encoder. how you will do this one from Escalon pre-processing, that is a class 1 hot encoder. Then you can create the instance of one hot encoder class. That is, I have given the name as the encoder, one hot encoder, whatever it is written. Then inside it, it just parse out what you may you cannot you it did not it did not need to write anything even. Okay, it will take automatically with this one. So DF location encoder this one dot feed transfer DF location. That means whatever was there, this one is converted into the encode into the numeric form. Then it is again stored to DF locations. Now, if you see this information, you see all becomes numeric. If you write this info, then when you run this one, you will find all becomes the numeric. Oh, wrong syntax. DF dot. Now see here all. Oh, I did not wrong this. Yes, see here, location becomes float value. Okay. So now you can use any machine learning algorithm because it is in the numeric forms. Then if you have any duplicate, you can remove the duplicate. All this thing I already explained you. I think I will not use. So let us go for the implementing the linear regression approach. So here some numpys, all this thing I already say you. These two are not needed now because I am already manually do all this thing. You can use this one and do, since time is not permitting. I'm not going to do. So here to do the scalar, I have included this one, but this thing is not needed since we are not use the any pre-processing model I am not creating here. So I can remove this one. So now I am use the linear regression. First of all, whatever data is there is combined with the target data. So what happen? You will drop the price is your target data. So you will drop this one, rest you keep in the X data frame, and Y is target data is give us the Y. Then what happened? This is not needed. So if you want to use a linear regression, let us use this one is your linear regression. From Escalon linear model, import linear regression. Regression model, I have given the name, this is regression model. Then I call whatever written right here, linear regression. So linear regression is called here. Then I feed that model on the data set here. X is here. You can standardize the whole numeric data on here. I have not standardized. Or you can call this standard scalar and standardize it. So here, what often X is, if you do that one, then result accuracy will be better. So X is equal to DF drop this. This is all features value. This is the type, and I correspondingly feed this one as per the syntax I discussed. Linear regression. Scalar linear model, import linear regression model, linear regression, then regression model is feed on the data set. Now you will train. When you run this one, the model is trained. Now you create this model, linear regression model. After creating this one, when you use this model for the new data set, suppose X new is a new data set, then it will predict the price of that. See here is a new data set here. X new, that is area square feet is 1000, bedroom is 3, bathroom is 3, floor is 2, age is 7, location is urban. Since location is urban is your not a numeric value, you have to again encode that one. So the syntax is X new location is equal to encoder dot transform X new location, that one, this one. Well, again, you need to convert it data frame, because what you run this model on the data that is in the data frame. So you have to convert it into the data frame form. So you'll run this one, it will convert it into the data frame. Then you will, when you run this one on the new data set here, so you find that the price is 206578.856. You can round it right here, the round, and whatever you want to calculation in you using the Python, you round off it or cut it or whatever you can do with it. Okay, in this way you can use the linear regression. Then if you want to use the k nearest neighbor, then the syntax is here from sklearn neighbors, import k neighbors regression, then create the instance that is knn model. I have given the name, that is here is the same, must be the same, but this model name I have given, that is kn neighbors regression instance is created. Again, it is fit on the x y features value and the corresponding predicted value. Then you run this one. After running this one, you will get the model. Okay, trained model you get. When you get the new data with this model, this new data is given to it. Here I have done the round off and take the integer value. Okay, so here KNN model, this is the KNN model name I have given, the dot predict x new. X new is same this one. Okay, so when you run this one, you get the value 206540. The previous one, linear regression, give you 206578. It is given 606540, which is the good. So we need to calculate this one. We'll discuss all this in the next class, how we'll calculate. Another is the k nearest neighbor for the regression, what I taught you. Let us see. So first is for the regression, we'll discuss here. First is linear regression. Logistic is your for classification. KNN we already discussed now. Then regression is used for KNN. And then is the decision tree. Let us go for the decision tree. Whether I have done or not. This is the decision tree. From sklearn tree, import decision tree. I have given the name tree regression model, that is the decision tree, whatever right here. Decision tree regression is inside. Then that instance, after creating the instance, the model is fit on the XY data. Then you have to run this one. After running, it will create the model. Okay. So it's to make the tree. You can see the tree. There is syntax there to see the tree. But tree will be very large. Oh, it will be look very small. You cannot visualize that one. So after that, when a new data is given, same new data, you will calculate the price. You will find 215650. Here I did not do the roundup. So you find, see the difference. Here we have 206,000. Here we have find 115,650. So difference, see the difference. You are finding which is the best one. So you have to find. Similarly, for the random forest, here I have used, you create, you have to first load that one from the ensemble. You are load the random forest regression. Then you have as I explained you in the PPT, it is created random forest regression NSE. Here I have do the 10 samples, 10 tree, and depth of the tree is taken as 5, and random state here I have written 0. You can write here 42. Okay. So then it is fit on the edge data to train the model first. So I same way dot fit xy. Then you have to run this one. After running, you train the model. Here the model is trained. If it is look like this, that means the model is trained. Then when a new data given to it, what you'll it will use 10 tree to predict. That means 10 prediction will come. Then it will take the, since it is the regression, all the values are added and divided the two, and what will be the value it will show you. So when you write this one, it will show that 20,000. 207,732.60. So in this way, you will do the regression approach. Then we'll discuss about the classification one. I think time is over. So this is hello.
Yes, yes, we are audible.
Should you should we continue or because it's the classification?
Yes, your voice is breaking.
I will start.
How much time it will take?
Approach. I have to. I already did some approaches. One approaches I have done. I have to do rest 5 6. I have to type that one. It will take time, sir, 30 minutes.
Okay, otherwise you can stop. Your voice is also breaking. I think tomorrow you can do the same thing. So at what time tomorrow you can join? At 11:30?
Yes, sir, 11:30. Because at 2 I have the exam duty. I have to go 1:30.
Well, I think the net is not so good in your, at your home, so that's why voice is breaking throughout the session. Anyhow, so whatever the assignment students are asking, I think tomorrow for the assignment tomorrow we are going to discuss, and ma'am will give the
Yes, sir.
assignment on this only. She is supposed to give some 5 to 6 data set, and whatever things covered till now, you have to implement all those things in
Hello.
Google Colab. Fine. And if you are able to implement, then it's good, well and good. If anybody having any doubt, then ma'am after comes in the next week, ma'am will come and again explain all the 5 data set assignment to you. Okay, so at that time you can clarify yourself, because a lot of students are there. It is
Yes,
not
sir.
possible to verify one by one. Okay, so you just do the things, whatever problems are there, you can ask. That will be interactive session, and ma'am will also tell from her side the steps. Okay,
Okay.
I think we can stop here, ma'am. So
Okay, sir.
voice is
Okay.
also breaking, and it will take time. We can stop.
Okay,
Thank
sir.
you. Thank you all, and recording will be uploaded today only. Fine, by today. Thank you very much.
Okay.
Anyone having any questions, you can unmute and you can ask. Otherwise, you will stop here.
Any question?
Anyone having any questions? Okay, so they are not in a mood to listen more.